And picking up from our last list, I'm going to show at least two reasons why for expressions are better than using getOrElse. And so the first thing I'd like you to do is imagine that you ask a user to input four integer values as strings, and then you would sum those up like this, as I showed in the previous lesson. And if you assume that they gave you exactly what we were asking for, then those four strings will properly convert to integers like this, and then like this over here. So in the end, we get this sum of 10 result right there. And a note here that we call this the happy path for the for expression. And when I say happy path, it means that you got the input values that you wanted, and therefore the for expression completes properly, and you end up with this sum of 10 right there. So again, that's the happy path. Now, conversely, an unhappy path is going to look something like this. So you could come up here and say, kaboom right there on that very first one. They entered that string right there. And now when you hit enter, our sum value is now going to be a none in this case. So what that means is that one or more of the values that we were given could not be converted properly. So then the for expression stopped. And actually what happens, I think I discussed this in the book, but what actually happens right on this line is that the for expression stops at this point. So this fails right here. A none is going to come out of make int right here. And then the rest of this code is never even evaluated. And again, we call this the unhappy path because we did not get the input we wanted. But a cool thing about this is, did we throw an exception? No, we would never do that in functional programming. Our pure functions would never throw exceptions, and our algebraic expressions like this right here would never throw an exception. What we did was we got a value in this case, and that was the happy path, and we got a sum value right there. And then in the unhappy path, we also got a value that we can work with, and this was a none. And again, sum and none are both children of option. And that's why this code works the way it does. And the real key is we get values in both the happy path and the unhappy path here. These are values to work with, no exceptions. And I do mention in this area here that the code short circuits right there on that first one. So makeInt receives a string. It cannot transform into an int. So makeInt returns a none. The for expression short circuits at that point, and then the variable sum is bound to none at that time. And now what I'd like to do is compare that to getOrElse. I could see in this version of the book here, I have a problem. So when all else fails, let's go to the source code for the book and see what I did there. And whoops, you can see that is definitely a problem. We're going to need something like that and that right there to fix that problem. And what I'm trying to show here is the only thing you could do with getOrElse is assume that when makeInt fails, you have to fall back to some value. So question is what value you're going to fall back to, and in this case I fall back to a 0 value. And you'll see if I copy that code and then paste it into the REPL, we actually get a wrong answer here. So the answer is not 9. That is not a correct answer. The correct answer is a none because this first one fails. So that's why I wanted to show you two ways that using for expressions are better than using getOrElse. The first way is that you get a value in each case. So in the success case, we got the sum of 10. In the failure case, we got a none. And again, in both cases, we're working with values. We're not dealing with exceptions, and we're also not working with incorrect default values like this right here. And then as a note in the book here, if you think that's bad, I'm just using option event right here. And imagine what would happen if you use complex real-world classes like, an option of person or pizza or a list of friend. And so that's why experienced Scala developers will tell you not to use getOrElse. You can use it in some situations, but generally it's going to be wrong, and that's where you want to use your for expressions instead. So I just talked about all these parts here. If you want to read through this, feel free to pause the video so you can read through that right there. And then next, what we're going to look at is if what I'm showing in for expressions so far isn't clear, then what I want to do is clear up that confusion in the next lesson.